What is the difference between a scalar value and a vector value? Scalar and vector. What's a scalar?
What was it? Scalar, like non-specific, like form of no direction.
No direction. Magnitude has a size, but no direction. Therefore, vector has a direction, right?
Yep.
Right? Is well, let's do the easy one first, right? Is speed scalar or vector? Scalar.
Yep.
So the vector of speed, the vector quantity, scalar. We call it velocity. So if you want to sound really cool, right? Or if you want to say, hey, I know that because my physics teacher told me. Give it to me now. Thank you. Thank you. These don't exist. If you want to sound cool, when you're on an airplane and you hear the pilot say, we need to go around, we've been given vectors to go around the airport. They're actually given displacement vectors or most likely velocity vectors because they tell you which direction to go and at what speed, right? So they give you magnitude and direction. So they're basically giving you velocity vectors to make a square in the air to come back around to the airport to approach. Yes?
Can you show how velocity would be shown? Like how do you go in direction?
That's it. Now, I just draw that silly little arrow, right? And I say, this is, we'll call it some sort of 150 meters per second. Okay. Do we know exactly which way that's going?
No.
No, because I didn't say, due east,
Yeah.
due west. And we won't do a lot of that. We'll do some of it. We'll use the northeast, west, south idea a little bit in this class, but mostly it's going to be a positive or negative thing. Are we going in the positive direction or are we going in the negative direction? Cool? Only because most of the times, especially remember we were talking about resultants before, and one team is pulling this way, and another team is pulling this way with less force. Okay, we'll say this is 300 newtons of force, and we'll say this is 200, negative 200 newtons of force, right? So what's our resultant? Who's pulling more? The 300 guys, right? That's simple. So our resultant would be 100 newtons of force. And we would know, because it's positive, that it's headed that way. Unless I had decided that that way was negative and that way was positive. Because our scale is subjective. Our coordinate system is subjective. we get to choose as a whole. Good?
Yeah.
Simple. For now, that's all we need to talk about. Our lab, we have lab on Thursday, right? Thursday is our long day.
Yeah.
So our lab this Thursday is going to be the difference between distance and displacement. Distance, scalar. Displacement, vector. So we're all gonna stand up, walk out the door, walk over to the track.
When we said distance is scalar,
Distance is scalar, yes.
like the definition of distance says, even if it moves in many directions, but that's without any direction.
It is not.
You just said it doesn't have a direction, right?
Oh, okay.
Now, what's the vector for distance?
Say it again.
What's the vector for distance?
There's no vector for
There's no
distance.
vector. Okay.
Displacement. Displacement.
So there is a vector for distance.
So really the idea between distance and displacement is when we go to the track, we're going to walk all the way around, right? Start. We will have walked 400 meters, right? But our displacement is 0. So the joke is I take the guy who runs the 800, and that is the single hardest race in track, to run as fast as you can twice around the track. I say, why are you breathing so heavy? You haven't gone anywhere in terms of displacement. And they say, oh, sir, you're such a nerd. And I say, yes. And we have our little laugh, but that's the big idea, right? So now that we know the difference between scalar and vector, we're going to talk about our first vector quantity, and that's going to be velocity. So, should say it there somewhere. You're going to use position time graphs to find velocity. It doesn't even tell you. It's the next one. That's why.
Yeah.
I lied. I gave you the answer already. So you'll be able to read a position time graph. When you see a graph in physics, time is always on the bottom. Okay? Time is always down here. This can be almost anything. We start with position, where we are. Real simple. You see that first one, they give you a table, don't they? 0, 1, 2, 3, 4, 5. And then it goes 5, 10, 15, 20, right?
Yeah.
So they give you this scale,
5, 10, 20.
T and P, right?
Yeah.
Yeah. 0, 1, 2, 3, 4, 5, or does it start with 1? 0, 0,
0.
5. Oh, and this is in meters, I think.
It is.
10, 15, 20. The last one's 30?
No, 20. I was just testing this.
This one?
This
You just freaked me out, dude. And this is me cheating because I don't feel like it.
Whoa.
Oh.
You can't do that.
What, cheating?
Yes.
Legal cheating, right?
That will not lie, cheat, or steal.
It's not like that.
So,
Or tolerate those that do.
right.
Oh, shit. Shit. Got a fire.
So, after 1 second, we've gone 5 meters. 2 seconds, we've gone 10, et cetera, et cetera. Easy to read?
Yes.
These are so simple. Do I have to spend a lot of time on this? This is real easy, isn't it? I can move on. I can go to velocity.
He's gonna go over to get that.
That's fine.
Wow. That was mean.
But it's
Come on,
fair though,
X-ray.
'cause he just.
All right, so
Yo,
anybody in here taking calculus?
Well,
I'm the best.
And you've been doing this,
Yeah, we
right?
just did it.
You just did this, right?
Yeah.
Average what? Average rate of
Change.
change? Great. Excellent. Excellent. How dare you, sir?
by the way,
Grab a textbook on your way back.
by the way, everything is recorded on live stream on YouTube.
Oh, is it still live?
Well, what is it, Mr.
Yeah.
Soco Math?
Do the whole thing.
Damn.
Whole thing.
Soco
Thanks, man. I'm sorry. Everything all right?
Yeah, I'm good.
Okay.
Wait, sir.
I know. And guys, never be offended when I throw your pass in the trash. I don't need to keep it. I just need to see it. That's
So
all.
you know there's people
It's not like I'm
posting,
mad at you.
you know there's people posting like mass like lit classes on Pornhub.
Okay.
You should do that too. Sir, it sounds like a very lucrative.
Inappropriate.
Oh.
Oh, buddy, that shit's not recorded.
Okay, so calculus. Right? Instantaneous. Oh, this is average rate of change,
Yeah,
isn't
that's
it?
average. Yeah, instant.
What's instantaneous?
There's only one.
Look at the tangent.
Ah, line tangent. Oh, you guys are so smart.
I'm so smart, sir.
Secant is
Don't
average.
deal with the rest of them.
Hey. Secant, this secant line right here,
Yeah.
that's average. That's this guy. This line right here, the slope of this line right here.
I'm basically taking 2 calculus classes right now. Online.
Let's try.
Slope of that line is the average velocity. The slope of your position time graph is your average velocity. It is if this says so, we could pick a point and say it's our instantaneous as well, right? It's a straight line. When do we have to worry about instantaneous velocity? When we have a curve, right? So if the calc version of this bad boy, if we had a position time graph that went here, we'd still have, let me use a different color.
Red, black, red.
All I have is pink over there, red's over there, sorry. So we still have our average rate of change, right? But if this is a guy running 100 meters, basically what happens, right?
Yeah.
Because you start from nothing and you have to accelerate. And you're almost done accelerating by the time you get here. Does that make sense?
Yeah.
Anybody watch the Olympics?
Yeah, I do.
Yeah.
Which one?
Cool stuff, right? Cool stuff.
You just go over the instantaneous and how.
So instantaneous, I just want to show the difference. The difference. This is baby physics. All right?
I'm baby math.
Algebraic only. So we're not allowed to, I want to find the instantaneous velocity here. I find a line tangent. It's so hard to do it perfectly, but at this point, my slope is steeper than my average, right? If I tried to find a line tangent up here, it's even steeper. Okay? But here in this class, we won't be doing it. You know why? We have to take a derivative. We haven't learned how to do that yet. Like you haven't learned how to do that yet in calculus. You haven't even gotten the limits yet.
We're about to.
You're about to, right? But you haven't taken a function and taken the first derivative
Is it a power rule?
right?
It's a power.
Yeah. And then input a time. Now you know you're instantaneous. So you're good. Yes.
So that's how you.
Yeah, that's the idea. Now, are there other ways to do it? Yeah. Product rule, chain rule, quotient rule, OD high minus ID ho over ho squared.
We're still doing this slow form.
Yeah, it takes a long time, dude. I know you're ready to go. I told her you're ready to go.
So you tell her about me too?
Yes, we did limits at the end of pre-calc. Okay, so at the end of the year, we're gonna do limits and we'll start our process. Let's get back to where we were. So. Average velocity. It says it right there, doesn't it?
I don't know what you.
Doesn't it say it? The next section? No, the next section. Next section. It's only a couple pages. Doesn't it hit there?
Let's see. How fast? Change the position divided by the time. Is it just?
Okay, so velocity
Delta X
is change
position.
in position over the amount of time it took, right? Simple as possible. Right, that's our next big formula. I've moved on to the section 4, sorry. Everybody make sure you're on section 4. Sorry.
46.
Nice nap? Oh, you put one page, your head was down, I figured you might be napping.
I'm here.
Everybody else is on page 46 or 47. Plenty.
Give me a time to learn. Get educated.
What do you want? 20 minutes, right?
Yeah, 25.
30 minutes. 25 minutes.
I have an hour, 15 minutes.
Good.
I could deal with that.
Average velocity.
Wait.
Oh, should they?
Only one is.
Let's go back.
Here's where you guys are going to hate it. So I have a position time graph that looks like this, right?
Yep.
I'm also going to have a position time graph that looks like this. Direction. Time, always positive.
Of course.
Can have negative time, right? You cannot go backward in time. We've discussed this unless you break the universal speed limit of 300 million meters a second. You can't go back in time.
The car's gonna pull me over.
By the way, the police won't see you if you're breaking the universal speed limit.
What about the universal?
If you are moving the speed of light or in excess of the speed of light,
The cops.
we wouldn't be able to see you.
What about the universal?
Stop.
Time, please.
Stop. This is what I was saying.
Hey, you recorded. Hey, you recorded.
Wake up.
Now, when we're talking about position and time, this is easy. This is, right? This is -1 meter a second,
Oh, yeah, I got it.
right? We've gone in the negative direction. We've gone from 4 meters to 1 meter, right? 4, 3, 2, 1, 0. So we've gone from 4 to 0 in 4 seconds.
Uh-huh.
Okay?
Yeah.
But we've gone down. So we'll call it negative. So we're going -1 meter a second. Wait, it's going to get gross. When I throw up a velocity time graph that looks like that, that means it's slowing down and then speeding up in the other direction. But we'll get there. For now, this is just our average velocity. So our average velocity is -1 meter a second. Does that make sense? Because there is one of those in there. I saw it and got scared. It is there. Theirs is -5 meters a second, right?
Yeah.
It goes from 20 to 0 in 4 seconds.
Yep.
So we got -5 meters a second because you guys are good at math.
Yeah.
Good? Yes. If you need to. Hopefully the pass is still over there. If not, yeah. No.
Those people on toilets.
Good? All right, so this is basically what you need, right? Oh, nap time. Yeah. I wish I had one.
What do you mean, sir? Section 5?
We're there. I told you.
51.
51.
Ranking, right?
Thank you.
Turn to page 51. Turn to page 51.
Page 51, y'all. Thank
Page
you.
51. 51. 51. 51. 51. 51. All right. Now, this is speed, doesn't it? Okay. All right, let's look at number 40. Let's just look at the graph. Just look at the graph. Number 40 on page 47.
Right text?
51. Sorry, it's 47 in front of me.
Page 51.
51. Look at the graph. Let's talk about A, B, C, and D. Now, when we want to talk about who's going fastest, what do we need to see? Not necessarily positives and negatives, because you could be going in the opposite direction, but faster. Slope, right? So speed, which is the slope. So the steepest slope looks like A. A is, oh, I forgot you had your college class. Right. Thank goodness I'm recording this. You'll get the whole lesson. Does everybody see that A is the fastest?
Sir.
Well, you were there. Look at you. I thought you were. No, sir. Excellent.
Sir, Douglas never sleeps.
So A might be going that way. B's going the other way. Not quite as fast. C's going in the same direction as A. And D's going the same direction as B, but slower. Who traveled, who starts furthest away from the origin?
A.
A. Then who's next?
B.
C.
C.
And D and then B.
Then D, and then B's right at the origin. So we've decided that B is the real start line. Just because that's what we decided what the origin was.
What?
We set up our own coordinate system. We, as the physics students or physicists, make the decision as to what the origin is, where we want to start. Right? And then we hit the timer and watch it go. Yes? I guess so. Sure, have a great time. Everybody out.
Yeah, okay, let's go.
No.
Go.
So what I'll do, I'll find some simple, maybe I'll take a screenshot of some position time graphs. Type up a couple of questions to go with it, or maybe something out of the book.
Simple.
Yeah, simple. Simple questions, I'll post them. Should be easy. Probably 3, 4, maybe. Easy stuff. So what do we talk about today?
Position time graphs.
Position time graph, that's what we got here.
Average rate of change. Scalar versus instantaneous.
So I'm gonna ignore the calculus bit, right? We did talk about calculus a little bit.
Average velocity.
Scalar versus vector. Slopes, what's the slope of a position time graph tell us? Oh, thank God you're reading. Right? Thank God. No, it's great, thank God. Really, because it's all right here. Did you come in late for that? Whoa! You're already ahead of the game. You win. Good? So we got a little bit of information, and then, even though I erased it, they designate average velocity this way. I don't do that. I just say velocity is change in position over change in time. Or because we know that change in position and change in time are xf minus xi over tf.
Yes.
Is there a reason that while I'm talking and summing up, you decided you're done? Okay, cut it out, please. Oh, you're fine. We're good. That's it. The end. You good?
Yeah.
Any questions?
No questions.
Way too early.
That's okay.
Still lunch.
That's okay.
No, it's seriously.
Might get shorter on my bus.
All right, we got to go to the next section.
Oh.
It's this.
Just kidding.
2:30.
2:35.